All right, ever stop and think about what actually holds our modern world together? And I'm not talking about, big ideas like gravity. I mean the real, physical stuff. Well, today, we're going to pull back the curtain on a secret ingredient, a totally hidden element that makes, well, pretty much all of our modern tech even possible. I mean, just look around. We live in this age of absolutely mind-blowing engineering. We've got skyscrapers that literally scrape the clouds, machines that just obliterate the sound barrier, and these massive pipelines that snake for thousands of miles, even under the ocean. So what's the secret? How do we pull all that off?
No, seriously, just pause and think about it. Inside a jet engine, right? Those turbine blades are spinning in temperatures that would just turn most metals into a puddle of goo. Or picture a deep-sea oil pipeline. It's got to handle the insane, crushing pressure of the deep ocean and the constant, relentless corrosion from salt water. So how in the world do we make stuff that can survive conditions that are just that brutal?
Well, the answer isn't as simple as, say, just steel or aluminum. Nope, it's an additive, a secret ingredient. It's this hidden element that, and get this, most people have never even heard of. But without it, our entire high-tech world would pretty much just grind to a halt.
So, that element is molybdenum. I know, it sounds like something straight out of a sci-fi movie, right? But this metal is very, very real, and it's basically one of the cornerstones of our entire industrial world. So let's figure out what this powerhouse element actually is.
Okay, let's get the basics down. Molybdenum, its chemical symbol is Mo, is so valuable because it has this incredible combination of three properties. It's not just strong, it's not just heat resistant, and it's not just corrosion resistant. It's all three at the same time. And that amazing combo makes it an absolute superstar in the world of materials science. And here's what's so wild. You'll never just find a chunk of pure molybdenite lying around in nature. It's always locked away inside other minerals, mostly one called molybdenite. And in its raw form, this stuff is soft and dark. Honestly, it looks way more like the graphite in your pencil than some high-tech supermetal.
Okay, so if it starts out looking like this, humble, soft rock, how do we get to the super metal? How do we unlock all that incredible potential? Well, that journey from a graphite-like mineral to a supercritical industrial metal is a pretty fascinating process that happens in these massive operations all around the world.
Basically, we get it in two main ways. You've got your primary mines, these are the huge ones in places like Colorado in the US and in China, and they exist just to dig for molybdenum. But, and this is the surprising part, most of the world's supply actually comes as a byproduct. It's recovered from these enormous copper mines, especially in Chile and Peru, where they have to carefully separate it out from all the copper ore. The extraction process itself, when you break it down, is actually really clever. First, they just crush tons and tons of raw ore into a super fine powder. Then comes the cool part. They use this technique called flotation, which basically lets them separate the lighter molybdenite particles away from all the other heavy rock. What you're left with is this concentrated powder that's finally full of the molybdenum we're looking for. All right, so we've mined it, we've refined it. Now what? What do we actually do with it? Well, this is where things get really interesting. This is where molybdenum's true superpowers get unleashed. Because the real magic of this stuff isn't in using it all by itself, but in what it does when you mix it with other metals.
I love this analogy, it's perfect. Think of it as vitamins for steel. Seriously, just like vitamins can make your body stronger, more resilient, metallurgists add just a tiny little bit of molybdenum to steel. We're talking a small percentage. But that one small addition completely transforms the steel into something way, way stronger and more capable.
And I mean, this chart really says it all. A whopping 80%, that's 4/5 of all the molybdenum we produce, is used for one main job, making steel and other alloys better. When you see an element that's so focused on a single purpose like that, you just know that purpose has to be incredibly important. So what kind of vitamins are we talking about here? Well, for starters, it makes steel way stronger and tougher. That means it can take a massive hit without just shattering into pieces. It also dramatically boosts its resistance to corrosion, so it can survive in nasty places like salt water or around harsh chemicals. And maybe most importantly, it helps steel keep its strength even at crazy high temperatures. You know, the kind where regular steel would just get soft and give up. And we're not just talking about some obscure niche uses here. That incredible toughness I just mentioned, that's exactly what you want in military armor to protect soldiers. And think about your car.
Those strong, durable, but still lightweight parts in your engine and frame that make it safer and more fuel efficient? Yep, you guessed it. That's molybdenum at work.
But its superpowers don't even stop there. In what they call superalloys, it's the absolute key ingredient that lets jet engine parts run safely at blistering hot temperatures. It's also used as a catalyst in oil refineries, which is basically a substance that speeds up chemical reactions. In this case, it helps pull nasty sulfur out of our gasoline and diesel, which, gives us all cleaner air to breathe. It's even used as a solid lubricant in situations that are so hot that regular oil would just, poof, burn away.
So what's the big takeaway here? It's this. Molybdenum might not be a household name, but it is an absolutely critical element. It's like the hidden backbone that's holding up the entire technological world that we all rely on every single day.
Let's just come back to that number one. Last time, 80%. Think about what that means. The vast majority of our high-performance world, we're talking the pipelines bringing us energy, the power plants lighting our cities, the bridges we drive over every day, all of it depends on steel that's been beefed up by this one special element.
Without it, our ability to do, well, a lot of things would be seriously handicapped. Generating energy, flying through the sky, producing all the stuff that makes our world run, it would all be so much harder. I'm not exaggerating when I say it's one of the most important industrial metals of our time. And as our tech gets more and more advanced, its job is only getting bigger.
And that really leaves us with a fascinating thought for the future. As our technology keeps pushing the boundaries, we're going to demand even more from our materials, right? We're going to need them to handle higher temperatures, greater pressures, be more efficient. So the real question isn't if we'll still need this unsung hero, it's what new, incredible superpowers are we going to ask it to unlock for us next?